All right. Last time saya rasa ada orang nak masuk. Last time we discussed on this, and all these are in basic law, and including the Kirchhoff voltage law, Kirchhoff current law, and sorry, nak buang orang pula, nak remove orang. Okay, and all resistor in series, parallel, voltage divider, current divider, Ohm's law. This is all basic law. But despite for your study in this semester, we exclude Y delta transformation. You are lucky, okay? So for this part, just write down that you're not going to study Y delta or delta Y. Because why? Because if you refer to your introduction class here, there's no Y delta and delta Y. Can you see it? No, this one. No, well, Y delta and delta Y. Okay. Actually, that one is a method to transform something that maybe you're not going to, you cannot solve using series and parallel resistor. Then the other choice is to apply Y delta. That's the good thing of that. Tapi my concern is in your future lab, which is in lab number 1, you're going to study that. Not study, reapply the knowledge of Y delta and delta Y. So macam mana if we exclude Y delta, then you're not going to learn that Y delta, and then you're going to apply it in lab number 1. You just remind your teacher later that you're going to you skip Y delta transformation, so she or he will teach you in the lab. Okay, inshallah. All right, now practice 2.6. Last time we stopped here. Okay, still remember what is Ohm's law? Anyone?
Yes.
What is Ohm's law? Okay, voltage equals IR. Okay. What is Kirchhoff voltage law? Kirchhoff voltage. Summation of V of what? Where to apply that?
In a loop.
Yeah, or a loop, right? So if you look at here, you need to plus all voltages around a closed loop or a closed path or a loop. So this is a Kirchhoff voltage law. What about Kirchhoff current law? Kirchhoff current law. Add a node, what should you do?
Sum of current entering a node or a
equal to 0. The summation of current entering
and leaving is equal to
Equal
0.
to
and plus with the summation of all current leaving the node should be equal to 0, right? Summation of all should be equal to 0. Or not necessary at a single node like this, but maybe you have a boundary of the current boundary, then the summation of current entering that boundary or leaving the boundary also equal to 0. Okay, right, now this part we have practice 2.6. Practice 2.6, you're going to apply KVL. If you still confused which one is which one, you just look at the middle part. If this one is a V, then you're going to sum up all voltages. Where? Around a closed loop, like that. Okay, just look at the middle part. Okay, and then you're going to find the value of I. Okay, this one you are lucky because they already give you imaginary current. This is the imaginary current. So when they give you imaginary current, you just apply according to the rules. Okay, can someone or maybe all of you, you can try this one. Write down in the chat box here. Yeah, what this one equal to? If you apply KVL around the loop. Okay, KVL around the loop. Maybe you start from VA and then follow imaginary current. Okay, you can write down the answer here. Anyone? No one? Okay, I start. Negative VA. Because you're going to apply KVL, right? So negative VA, then this one entering a VA. You see a negative potential, and then
Plus
this one,
V1
yes, plus V1, then
plus
Plus
VB
VB
yes, okay. Now,
plus V2
Plus V2.
okay.
V2.
plus V2
Plus
V3
V3. Plus
And then?
V3. Plus V3.
Equal to 0.
equals to 0.
Equal
You
to
should
0.
you should write
equal to 0.
Don't forget that. So this one is your answer. Plus VB plus V2 equal to 0. Ada lagi satu. Plus V3 equal to 0. But the question asks you find I. Find I. Where is I? In the middle here. So how to find I? What should you do? If this is this type of question, usually they will put use basic law. Use basic law to answer this. So you know that what is a basic law you're going to apply? Ohm's law.
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 Lagi?
Kirchhoff
Kirchhoff current
Yeah.
law. Kirchhoff voltage law.
voltage law.
Lagi? Voltage.
Divided.
Voltage. Oops. Voltage divider.
Current divider.
And current.
Divider.
Current divider.
Yeah, good. Ada lagi? Or only this? No, right?
The
Why?
I think only this. Yeah. All right. Now, Ohm's law. Can you apply Ohm's law here?
Yes.
Based on this
Yes.
part? Yes. You're going to
Yes.
apply
IR.
where? Where? To how to get I, so that you use your equation here and then apply Ohm's law, and then you get I. Okay, maybe because this is a R, right? R and R, then you can apply Ohm's law. So what is the Ohm's law at R1?
V1
1
V1 equal to
I R1.
I
R1.
R1. Is it positive or negative?
Positive. Positive.
Yes. How do you know?
Sign.
Strength atas. Sign.
What sign?
Passive
What
Positive.
sign? Passive sign?
convention.
Yeah, PSC. So you have a plus here. Okay, plus here. So you should have a plus here. You don't need to write down that plus. I just let you know that this is a plus. Okay, what about R2?
V2 equal to IR2.
Yes, good. P3?
V3 equal to IR3.
Yes. All these are in positive or negative?
Positive.
Yes, all positive. Sebab
Yes.
passive sign convention says that entering current should have a plus sign. So since this is a plus, this also plus, then you follow the plus. Okay, and then you can substitute into the equation, and what will you get? Something like in the next slide, macam ni. Okay, you just rearrange and then you will get VA minus VB divided by this summation of all resistance. This one just straightforward, so I don't write down one by one. But I hope you do understand this, right? This one just you substitute into the equation here, here, and here. Okay? If you confused, you stop me. Okay, this one done. This law alone are sufficient to analyze many circuits. In fact, all these three, you can solve many circuits. Okay. And then this part, practice 2.7. Okay, before that, maybe this one, they didn't give you the imaginary current direction. So what do you think? Do you want to have a clockwise or counterclockwise current direction?
Clockwise.
Clockwise.
Clockwise. Why? Why? Easier. What
Because
about
the movement of the current is followed by negative to positive.
because
At
you
the
follow this one? Do you follow this passive sign convention here, or do you follow what? Oh,
yeah, the
this voltage source or the current source? Which one?
yes, the 10-volt source. I think I follow it.
Oh, you follow this one. Okay.
Yeah.
Basically, we can use both. Doesn't matter. But to me, if you have a current source like this, then you just follow current source much better because you're not going to change the direction of this current source. Okay, so depends on that. We just follow this current source direction. Even though I know passive sign convention says that current will leave voltage source like this. Okay, but if you have this one, then just follow current source. If you have current source, follow current source. Unless this one, we have another circuit here, then that's different story. Then you have to use your own imaginary current. Later on, we will have that one example for that. Okay. Now, if we follow this and start from VI, okay, VI here. Can you apply basic law? Use basic law to solve this. Okay, use basic law to solve this. What basic law you going to apply?
KVL.
KVL around the loops, right?
Yes.
Usually, I like you guys to write down KVL around the loop. Around the loop. Okay. So if you start from this VI, what do you observe? Current entering a current source here. Then what polarity you see? Because this is voltage, then you need this one, right? Okay. So what polarity you see first?
Negative.
Negative.
Negative V1.
Negative VI.
Yeah.
And then you enter
V6.
this.
Positive V0.
Positive.
V6.
Yeah. Good. And then
Positive V2.
V2.
and then
Positive
Positive 10 V.
yeah.
What is 10?
And don't put unit in the equation here. So just equal to 0.
10.
And then to make sure that you are doing a correct equation, you count on the how many branches or how many elements in the circuit. So you have 1, 2, 3, 4, right? So you're supposed to have 4 variable. 1, 2, 3, 4. Okay. So this is the correct equation. And make sure this one equal to 0. So far so good.
Yes.
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 Alhamdulillah.
Yes.
Okay, but we haven't finished anything yet. What is V2, what is V6, and what is VI? How are we going to finish this? Do you have any other clue? What to apply in order to solve for?
Use Ohm's law.
Law.
Yes, very good. Ohm's law. Where is V2 then? Ohm's law.
I
Okay, I.
two.
I
UKI.
I of
I two K.
is it the same I through V6 and V2?
Yes.
Yes, right. So you
Yes.
yes.
one variable, just I. Okay, then this is I. V equal to IR. So what is that? R for V2?
Two.
Okay.
2K.
2 kilo.
Okay.
Please remember to put the prefix. Prefix, yes, you can put inside the equation. Okay, is it a positive or negative? Always question yourself. This is positive
Positive.
Positive.
because current should enter a positive polarity for passive element, which is this resistor, right? So it's supposed to have positive. What about V6?
I
Equal to
I
positive I
6K.
6K.
Yeah. Okay. Majority of you said I6K. Good. Then can we solve this
uh,
or not yet? Okay. We rearrange our equation. Vi. Or should I just give you Jamboard and then you write down? I 6K plus, is it a plus? Yes. I 2K and then minus 10. Okay. That's solved belum? Not yet. Then what should you do?
Yeah.
What should you do? Sudah.
Kat VI tu ada
Mana
5
ni?
ampere.
substitute the current.
Yeah. Yes, substitute the current, right? What is I?
5M.
5M.
How do you
5
know?
M.
It's 5 milli. 5 M can be 5 mega. Just say 5 milli. Okay.
Small m.
Small m, no, 5 milli. Okay.
5 milli is small, right? M dia small.
Okay. All right.
Mega dia besar.
So what VI? VI is equal to? Boleh ke ni? Sekejap. I tak ada R. Okay, tak payah. Okay. So substitute that I, you have a I is 5 milli, and then this 6K and 2K. How do you do this one? You can plus, right? So you have a 8K minus 10. So this one is 5 milli into 8K minus 10. You have what? 40, right? 40 minus 10?
30.
Then this is invoke or what? The unit.
Negative.
Yes, vote. Don't forget the unit. Okay, VI is done. Then what is V2 then? Or V6? How to get that? Can we get the answer or not? Yes, right. Because this is all straightforward. 5 milli into 2K. Then you have 10.
10.
This one? 5 milli, 6K.
30.
And you have
30.
30. Done. Okay.
Madam, minus 10 or plus 10?
Minus 10 or plus 10, which one? This one, V2.
Yeah.
V2. V2 should be a plus. I think plus. 10 Yes, pull off. Plus 10 because I is in this direction, right? Do we have answer here? I don't have answer. Tapi this is a plus according to this persistent convention here. And then yeah.
How about the VI?
VI here also 30, a plus.
You buat minus 10
Madam buat
Minus
minus 10.
Kena buat minus.
dekat calculation you.
Oh, this one Oh, this one plus, right? This one plus right?
Yes.
So this is
Yes.
berapa tadi? 40. So this is 50. 50, right?
Yes.
Yes.
Thank you. We don't have answer here. Tak apa. Tapi this is the correct way. Yeah, you just rearrange the thing or you can do the substitute 30 plus 10 plus 10. So 3, 4, 5, 50. Yeah, correct. Okay. I confuse you, right? Okay. Now this one. Use basic law. Okay, what current direction you going to apply here? Counterclockwise or clockwise?
Clockwise.
What? How do you know?
Already given.
You just follow the given one.
I0.
I know. And then what to apply next? What do you think? KVL.
KCL and KVL.
KVL and KVL.
Yeah. If you're going to apply KCL, where to apply KCL here? Macam mana? If KCL you have only one, maybe one here or maybe one here, but the current is the same current because they are in series. So you don't need KCL in this equation, I think. Right? Do you agree?
Agree.
Yes.
We agree.
Okay, good. So on the KVL at node at around the loop. Around loop. So what is that KVL? Start with this.
-12.
Okay. Okay, then
Plus
Positive
V.
2 VO.
how do you know positive?
Positive
Mm.
sign convention.
I see.
This one, right? Passive sign convention says that current entering a passive element should have a plus. So you have a plus here. And then plus what?
Oh,
4 K, and then
I.
IO.
Yeah. With I node.
I know.
How do you know this one?
Ohm's law.
Ohm's law.
Voltage, right? Voltage equal to IR. Then you need
IR.
to have I node and 4K. And then
Plus
2V0 plus 2V0
2V. Plus
2V
2V
node.
not.
Okay, good. And then
minus 4.
4V.
minus 4. Okay. Then
Minus V0
Minus V not.
minus V node equal to
0.
0.
yeah. Okay.
Yeah.
How many variables we have in this equation?
3.
2, right? Because V node and V node same. Then we have I node, 2 only. Okay. Can we solve this? No, right? Not yet, because this there are 2 unknown. So you need to apply another thing. What you are going to apply? This is 1. If I rearrange, we have 12 plus 4, which is 16. And then we have V naught. And then we have 4KI. No. Okay. So what is V naught equal to?
Equal to I.
I not
6KI.
6KI.
Is it a positive or negative?
Negative.
Negative.
Hmm. So positive,
Negative.
negative. Even though entering current says that you have a positive polarity for this specific sign, but since you have this one, a negative sign, then you need to have a negative here. Then you apply inside this equation, you have 4K I naught and then minus 6K I naught
Okay, I
equal to 16.
okay.
Okay, then you rearrange, you have what? Negative 2, right?
Okay, I
Negative 2K.
okay.
And then this one is equal to negative 8 milliampere, right? Okay, so far so good.
Okay.
And then what does it mean by this negative?
Current is flowing the other way.
Yes, in opposite direction of what you first assume. You assume this direction, but the actual one is actually this direction.
Anti-clockwise.
Yeah, okay, good. All right, now we haven't finished our V naught. What is V naught then? V naught equal to, based on this, 16
Over 4K.
kita dah ada kat sini kan? Oh, sorry. So we just use our equation here. Then V naught equal to minus 6K into negative 8 milli. And you have what? Kilo and milli. You can cancel out. And 6 into 8, 48. Make sure you write down the unit. My intention is to give you guys assignment and also quiz using the not MCQ, maybe subjective. Subjective means there's a question and then you're going to calculate something and then you're going to write down the answer macam ni. Okay? But please write down the value and also the unit. If you have prefix, then write down prefix. Let's say the prefix is micro something. Yeah, it's hard to write down micro, so you just write down U of something. Okay. If milli, then just milli, maybe millivolt, then you write down millivolt. 48 something millivolt. Because the system will mark your question. Okay. Any question? Or are you confused with the previous practice 2.8? No, eh? Okay, now this one. Find IV, I7, I2, I3, VI. Use basic law to solve this. Okay, what basic law are you going to apply?
KBL.
KVL, where?
Both
Both loops, right? So what, if you're going to apply KVL, you need to have imaginary current. So on your right side, you're going to apply counterclockwise or clockwise direction.
Counter.
Counter.
Why?
following
Follow the current source. Okay, good. Now, what about this on the left side?
Clockwise.
Clockwise.
Right. Yeah, both can. You want to apply counterclockwise, okay? Anti-clockwise, okay. If you want to follow passive sign convention for this one, yes, you can do this. Or if you want to follow this, yes, you can do this. Or the other way also can. But you need to observe your passive sign convention. Okay. Now, what is KVL around loop? Left, no, not left, right. Right loops. Okay, what is that? KVL on your right side here. Start with VI.
Negative VI
Okay. Then
Plus I2 20K.
I2 20K. Then
Plus V3.
Plus V3.
V3.
and then
0.
Equal to 0.
zero.
Equal to
Yes.
0.
Yes, because you entered this one, it should have a plus. And enter this one, you should have a plus. Since this one equal to this, then you just follow the plus sign. Okay, what about on the left side? Around left loop. Start with 10 volt.
Negative 10.
Negative 10
Negative 10.
Uh-huh.
plus
I7.
I
70K.
70K. I what?
I7
I7. Then
plus V
Plus V3
okay.
Equal to 0.
equal to 0.
Sekejap ada orang nak masuk. Siapa lambat ni? Okay, dah hilang. Okay, good. Now how many unknowns you have in both equations? Can you solve this? The first equation you have 3 unknowns, right? 1, 2, 3. The second equation you have 2. So 2 here. Then yeah, obviously cannot solve yet. Then what other equation you're going to apply?
KCL, madam.
Yes.
KCL. Yeah.
Where? KCL. Where to apply KCL? Where?
Between the resistor.
The resistor. Which one? At node, right? KCL.
Benar.
Yeah. Yeah.
This one or this one? Or this one? This one? Or this one? Or
This
this one?
one, right?
This one, this one.
Semua this one. So this is A, B, C, D, E, F. Which one you like?
A.
Let's see. If A, then you have how many current into A or leaving A?
2.
1, 2.
2
Are you sure only two?
2, 2 into 1, 1
Okay.
living.
Yeah. Into we have 2. What about leaving?
Living I3.
1. I3.
1. Okay, good. And then can we solve this or not yet? Not yet, right? So how to solve this one? Kejap. This is I7. I7, yes, you can substitute. This for I2. Yeah, you can substitute. But do you have any suggestion or what is I2 equal to?
I2 is 5 milliampere
How do you know that?
from the current source.
Yes, from this. So obviously this one should follow this 5 milli. So I2 is 5 milli. And then do you have any other suggestion of answer here? I7, no, we don't have anything. I3 also no, right? So can we substitute something to something? Okay. Any other suggestion? What is V3?
I3.
30K?
I3.
Is it positive or negative?
positive.
Yes, positive. So this one should be positive. And yeah, you can substitute. If this is a I3, and then I7 also have I3, so we just rearrange. I3 minus 5 milli. And then you can substitute into, if this is first equation, and then this second equation, and this is third equation, you will have I3 here, I3 here, into this, right? The first equation, substitute 1, no, substitute 2 and 3 into 1. So you have, just rearrange, you have 10 and 70K, I7 is I3 minus 5 milli, and then plus the V3, which is 30K I3 equal to 0. No, not 0, 10. Okay. And this I2 is equal to 5 milli. And Vi equal to V3 minus, not minus, plus 5 milli into 20K. So you can cross, you have V3 from here, but you need to find I3 first. So what is I3 equal to here? You do your math here, 70K. I3 minus equal to 10. Okay, and then you will get 3.6 milli, right? And then you can substitute into equation 3. This is number 4. Substitute 4 into 3. You will get V3 equal to 30K into I3, 3.6 milli. What is this equal to? I don't have calculator, but you can find it. Apa? 8. 10.8, right? 10.8. Is it? Saya salah. Sekejap.
108.
108.
Yeah.
There's answer ni. Ada ke answer? Yep. Mana answer? No, we don't have answer. Tak ada answer. So this one berapa tadi?
108.
108. V. Yeah, because we have 0 here, right? So 108. Okay, good. And then we can substitute into this equation. So 108 plus 100. So you have 208 mV. Is it correct? So we have VI done, V3 done, I2 yes, I3. Where is I3? Sekejap, saya nanti awak pening. Draw.
3.6. Question number 4.
3.6 apa?
Equation number 4 is I3.
Okay, good. We have this I3, you have this V3, you have this VI, and I2 equal to, did I write somewhere? No? I2 equal to 5 milli. Done eh? I7, where is I7? Oh, I7 we haven't done calculate this one. So I3 equal to 3.6 milli minus 5 milli. Then you have what? Someone calculate for me? 0.4?
Negative 1.4.
Negative 2.4
1.4.
milli, right? Milliampere. So this is the answer. Okay, good. Okay, good job. Okay, so I7 done, I3 done, I2 done, V3 and VI. Okay, good. Okay, do you have any question? I know this is say behind. Okay, tak apa. As long as you do understand, then okay. Do you get me or you confused? Huh? Are you okay? You just substitute into the thing and then you apply maybe KVL, maybe KCL. Just reapply the basic law. Okay, okay. We're done with that. Resistor in series and parallel. And then now we go for, this is just a recap. Resistor in series, you can add up. You can total it up. How they derive? By applying KVL. So what is this? This one basically, you apply KVL around this. When you apply KVL around this, you will get this equation. And then you rearrange all resistor at one side. Why? Because here, the IS here, we have the same current flowing through a series circuit. So in series circuit, you can total up all resistance in this series circuit. And this series circuit is actually equal to R equivalent. The total of all resistance equal to R equivalent. Okay, so resistor can be added in series. Or how about voltage source? Since we apply the KVL in series of a closed loop like this, all voltages can be added in a series. So all voltages you can add. Okay, meaning to say if you have a voltage drop across R4 here, then you can add up. Okay, and then electrically there is no difference between the two circuits. This and this, they are same. Because why? Because we have one voltage source and then a resistant or a load, something a load. So this all here are one single load, load. Okay, what about resistors in parallel? A resistor in parallel, you have everything in parallel. Okay, before that, maybe the theory is if you have in series, two elements is connected side by side. So you have one single node in between them. But if you have elements connected in parallel, you should have something like this. The end of both are connected. Macam ni. So you have a 2 or 3 elements are connected end to end like this. Okay, for parallel. This is parallel and this is series. Why I teach this this, I think it looks okay, but maybe in future you're going to have something almost similar, but you will confuse. So let's say I have some resistor here in between of this R1 and R2. Do you think this is a series or parallel or what? If you have this, is the R1 and R2 parallel or not? What do you think? Are they parallel?
No. Series.
Series? Are you sure this is series? Because you have another one here.
Oh.
Ini another loop.
Are they parallel or series?
Tak sure.
Not sure, right? Not sure. So you go back to your theory. If you think that this is connected end to end like this, then they should be in parallel. Are R1 and R2 connected end to end? Yeah, despite connected one side. What about R1 here and to here? This R1 here and R1 and R2 here, there's something, right? There's one element here. So this element actually blocking that. Then there's no one single connection. Because of that, you cannot say that this is in parallel. So this is not in parallel, okay? Not in parallel because of this element. And then if you say that this is in series, because it seems like a series, right? But you need to look at what are the element attached to it. So if you have something like this, they are not in series. Something you have this, this, and this, right? So they are not in series. Series should be something like this, a total one single loop. Okay, that's why if you have something like this, you need to reduce the circuit from this side, and then over here you can have a series circuit, and then further decrease, and you get the answer. But that one later on, I will show you how. Basically, there's another way to solve this type of question, is to apply y delta and delta y into this part. But that one we will exclude. So we just focus on the case, this part first, parallel. Later on, I will show you how we can reduce our circuit, then we apply the theory. Okay, so resistor in parallel, make sure this is all in parallel, which is all connected at single line here and all connected at this end. Then this one you can see that they are in parallel, and the R here, you cannot add up because why? Because if you apply KCL at this loop, you're going to have I1, I2, I3, and I4. So based on that, this current leaving should be equal to current entering. And then you rearrange, all voltages in parallel should have the same voltages, right? Voltage across V1, V2, V3, V4. All these are equal to Vs. So you just write a single Vs like this. Okay. And then rearrange, you will have this resistor, reciprocal of resistor, which will be equal to this equivalent resistance. So it's either you write down like this, or you can also write down in terms of this one is R1 inverse, right? Plus R2 inverse, plus R3 inverse, plus R4 inverse, equal to inverse R equivalent. Okay. Why I write like this? Because when you do your calculation, somehow maybe some of you will do this part. It's quite difficult to use your calculator, but because if you rearrange, let's say we have only two, this part. So R equivalent will be equal to R1, R1 and R2 plus R1 plus R2. Is this correct? Because I am putting. Yeah. This is not inverse, okay? This side. So it should be something like this. But I don't want you to apply this rule, okay? Do not apply this. What should you do is you just do R equivalent equal to R1 inverse plus R2 inverse, and then put inside a bracket inverse all. Then you will get the R equivalent. Okay. This one you can do using your calculator. I don't want you to apply this because it's quite complicated. If you have 4, 1, 2, 3, 4, then you need to multiply all and then divide by summation of all. So what should you do? Just do like this. Okay, we remove this and put all inverse. All answer here inverse. Later on, we will revisit, and then you will save your time by doing your calculation like this. Okay. Do you get me, or are you confused? My point is please do not use this this way. Use this part. Okay. Please use this part. In order to use your calculator, please try use this. Do not use this. Even though the equation are same, but just save your time. Okay. For conductance, you just inverse the resistance. So you will have this. Okay. This is what I mentioned. R equivalent is R1 plus R1 into R2 divided by R1 plus R2. But do not use this. Use R1 inverse plus R2 inverse. Do you have calculator with you now?
Yes.
Yes. Okay.
Yes.
Can you see the inverse sign in the calculator? Or on your calculator, you have inverse sign.
Yes.
Yes, right. So
Yes.
it has some value, and then you use this inverse sign, and then you plus with some value, use this inverse sign, and then find the total, because this plus, right? Just equal that, and then inverse your answer. You have your answer, then you inverse. Then you get the R equivalent. Okay. This is how you use your calculator. Please do not use this one. No, I don't want you use R1 into R2 divide by R1 plus R2. No. This one you will, majority of students who use this, they tend to do careless mistake because this one should be in bracket, right? Just be careful. Okay. Now voltage divider. All right, voltage divider. Maybe I should insert another new slide. Okay, what is voltage divider? Okay, a voltage divider always have a voltage source. Maybe this is a resistor 1 and resistor 2. Then this is a voltage source. You have a voltage drop across R1, and then you have a voltage drop across R2. So in order to use a voltage divider, first make sure this is in series. Okay, this is a series circuit. And then this one, make sure this is a voltage source. And then, yeah, you're going to find voltage 1 and 2. So that's why they call it a voltage divider. And then what is V1? Okay, you need to have this first into what? Okay, if this is a V1, then the voltage drop across that element should be here. So the element for V1, the voltage is drop, the voltage 1 is drop across R1, right? So this one should be the element. And then you need to divide by summation of all in series resistance. So R1 plus R2, just that. Okay. And then V2. What is V2? Anyone can tell me? You need a voltage source. Okay. And then what should you do? The voltage to drop across what element?
R2.
R2. And then divide by summation of all in series resistance, right?
Yes.
Okay. Bear in mind that voltage divider will not tell you the sign. Okay, the sign. What sign? This sign. Okay. So what should you do? You need to tell yourself that this is a positive or negative. How do you know that? It's by looking at your polarity. Okay. If you have a voltage source like this is a plus, and then this plus meets plus here, then this one should be a positive. Okay. Plus meets plus, then this is a positive. What about V2? This is a plus sign, and then?
Negative.
Positive.
Positive, right? Because this one meets positive. So it's a positive. What if I change the sign for V2? Okay, let's say I change the sign for V2. This is a negative. And this is a positive. Now, what is the sign for V2?
Negative.
Yes, negative. How do you know? A positive,
Positive, negative.
negative. So you have a negative here. Okay. So far, so good. Yes.
Yes.
Yeah, good. Okay, now we proceed to our current divider. Current divider. Before that, do you have any question for voltage divider? What if we have three elements? One, or two, or three. And there's a voltage drop across here, which is V3. Oops, tak boleh tulis dah pula. Dia nak Liverpool pula. Sekejap. Okay, V3 here. This is Vs. We have three elements. What should you do? What is V3 equal to? Volunteer. Any volunteer?
VS R3 over R1 plus R2 plus R3.
The first information you're going to have, what is that?
VS.
Dah tidur ke?
VS.
Okay, brothers and sisters, right?
VS.
Yes.
VS.
We have three elements here. One,
Yes.
two, three. Okay.
Madam.
Here in series, yes. Then you're going to apply voltage divided to 5 V3. Okay. And what is the first information that you need?
VS.
Yes.
Kena bagi hadiah ni baru ada semangat.
Yes, madam.
What is V3 equal to? Did I mute myself or what? No. Oh, sorry. I accidentally mute myself. Sorry.
Yes.
Masa pula. Ya Allah, Tuhan. Okay, good. This is VS. Alright. Okay. Now, what is this one?
R3.
R3.
And then divide by what?
R1
plus R2 plus R3.
Wow, that's good. Okay. Is it a positive or negative sign? I just give this one.
Negative.
Negative. Yes. Okay. Can we proceed to current divider? Oh, you're already ready.
Boleh.
Okay. We have this. This is R1, R2. This is a current source. Okay, current divider. A current divider is when you have a current source in parallel with elements. Element here, element here. Okay, then you can apply current divider. But sometimes they will not give you current source here, but you can find a current source flowing through here. Sometimes they give you a voltage source like this. But still, you know that this part, if this is a voltage source, the current delivers from this V source, it should have a current. So this is IS. So you still can apply current divider. But we want to make your life simpler, then I just give you IS first. IS, and this is current source. Okay, make sure that one a current source there, and then make sure they are in parallel. And then what you're going to check, the I1 here and I2 here. Okay, so what is I1 equal to? like voltage source, voltage divider, you need the source. So just put source. But this one a little bit opposite because this is a parallel circuit. If you're going to find I1, then you're going to find the element, the element across it. So this one should be R2, and then plus anything in parallel, R1 plus R2, something like this. So you're going to find I1 here, I1, but you are not using this R1, but you're going to use the opposite of that. So this is R2. Okay. What about the polarity? Polarity, or later on I will show you on the polarity. Right now just put I2. What is I2? You need the source. Yes, I source into what? Anyone can guess?
R1.
R1.
R1 divide by?
R1 plus
R1 plus R2.
Okay. What about the polarity? Okay, this one, current divider will not tell you the sign, so you should do by your own. You need to tell what is the polarity of this I1 and I2. So how to do that? You look at the current direction here. If this one is in opposite direction, something like, yes, it's the same direction. If you follow like this, then this is a positive. But if you just look at this is going up, this is going down, then this one should be a plus. This is going up and this is going down, then this one should be a plus. Yes. Like, okay, that's that current direction. But what if we have three elements? IS, this one, and this one. We're going to find here I3. This one going up. This is R3, R2, R1. So what is I3?
IS.
IS
Into?
R2.
R2.
R1 plus R2.
R1, R2.
How to find this part? Opposite of this. Macam mana tu? They are in parallel, you need to find R equivalent, right? R equivalent. Okay. The R equivalent of this, so it should be opposite of the current across this one, right? No, the current through R3. So the opposite of R3 should be R1 in parallel with R2, which is this R equivalent. So you just put R equivalent here and then divide by?
R1 plus R2 plus R3.
Okay. R equivalent plus R3. Not R1 plus R2 plus R3, okay? So what is R equivalent here? R equivalent is equal to, you already learned how to find this one in parallel, right? R1 and R2. So R equivalent is equal to R1 and I like to do like this sign. This is a parallel sign, okay? So this one should be R1 inverse plus R2 inverse and inverse everything. Something like this. So it's either you write down R equivalent like this, or you can write down in terms of R1 in parallel with R2. And this one, R1 in parallel with R2. So far so good. What about the sign? Is it a positive or negative?
Negative.
Negative.
Because they are in okay, negative. So this part, please be careful. Please be careful, right? This is our equivalent. Okay. Any question? Any question? Or you still need some time to digest?
Yes.
Okay. Tak apa. Nanti you can go through the video, insyaAllah. And yeah, this is what they mean. This is current divider. And then this one is to apply y delta or delta y, but we skip this part. Yeah, this is y delta transformation, and still this is y delta transformation, but maybe I shall give you this one. Okay, all right. Anyone to volunteer here? Maybe I shall give you Jamboard. Do you like Jamboard? So that you can draw. Or if you have your own, sorry. If you have your own paper and pen, yes, okay. But if you have digital pen, then you can apply here. Kejap now. Where is the whiteboard? Choose from drive. Okay, let's share. Okay. Done. So, okay. Oh, dah ada. I shared a gem. Oh, dah. Ni, okay. Bila pula saya share? Okay, awak pakai this one. You use the link. Same link. Then we can use our Jamboard to find this. Find the R equivalent at terminal A, B. Okay. Right, good. All right, you can try here. Anyone? The question asks you to find R equivalent at terminal A, B. Okay, you can draw. I give you this whiteboard so that you can draw. You can rearrange this and then find series and parallel. Redraw the circuit. Find series and parallel circuit. Okay. This is R equivalent. Anyone can volunteer to draw and then maybe discuss. You can unmute yourself and then discuss with your friends here. Where to start first? Maybe you can start from A, or maybe, what do you think? 5 and 20, are they in series or parallel? You can discuss with your friends. Or is there any parallel resistors here? What do you think? And which one? Which one is in parallel? Yeah, please unmute yourself. And then you use this thing. Use the board. Only 16 in the gem board. Why? You get the link, right? You can use pointer if you like. You can start here or here. Discuss something. Hmm. Or do you want me to give you some time? Hmm. Okay, please discuss. I want to see your creativity. Is this the way you discuss with your friends? In silent mode. Aduh. Senyap je. Ya Allah. Baik betul. What is that? City? Apa tu? Is it? Oh, is it? Okay. Alright. Yep. This is A. And then which one is 10? 10 ohms. Which one is 20? And which one is 8? Okay. Alright, 10. And then 5. 5. Okay, the one is C. Then the one is connected. Okay, good. C with F. Then 6. 6 and 3. Where is 3? Macam mana tu? And you say that this one A connected to D. You can do concurrently. If you don't like this answer, then you can do here. Maybe someone suggest answer here, and maybe someone suggest here or here. Oh, okay. Then you say that this one 10, right? Okay, 10. And then this is D. D. And then you have 5. This is 5. Okay. And then this is C. C is connected to F. Okay. And then this is 6. And this is E. Okay. And then this is 3. Where is 8 now? Where's 8? 8 supposed to be here? Or where? Over there. Are you sure? E is here. E here. So E is supposed to connected to 8. If this is 8, and then what is this one? This 20? Ni apa? Okay, another suggestion. All right. This is A. Okay, this is A. This is 10. And this one? D, right? D. Okay, this is E. This is 10. 8. Okay. And then what is this? Oh, apa tu? Okay. D. This is 5 and 20, right? And then this is C. This is F. And E. And this is 6 and 3. Do you agree with this one, brothers and sisters?
Yes.
Okay, good. Now, which one is in parallel? Which one is in series? This one wrong because you still need some 8 there. So this part confusing. Okay. Can someone highlight which one is in series and which one is in parallel? Maybe parallel first. You can use pointer. Okay, this is parallel. This is also parallel. And then which one is in series? Are there in parallel here? Brothers and sisters, 10 and 8. Are they in parallel? This one?
Yes.
No. Yes?
No.
Why yes? No, because they are not connected. If this end connected with this end,
No.
then they are in parallel. Okay. Ni siapa punya conteng ni, ya Allah. Macam mana saya nak buat Okay. So, alright. Write down the equation. R equivalent equal to what? Okay. R equivalent equal to this one in parallel. Okay. So 5 and 20 are in parallel. 6 and 3. 6 and 3, they are in parallel, right? So 6 parallel with 3. And then this one, are they in series? This part?
Yes.
What do you think? Yes. And also this one also in parallel, right? Yeah, parallel plus series.
Series.
Yes, series.
So write down that equation. Okay, we start with 10. Okay, you continue. 10 plus, okay, plus 5, okay.
1/5.
Uh, okay. 5 and 20 in parallel.
Then 1/6 plus 1/3.
Okay. And what about 8?
Plus 8.
Plus 8. Okay. Plus 8. Where's 8? Tapi please do not write macam ni membandingkan kepala. What should you do is you write down like this. R equivalent is equal to 10, then plus, because they are in series, and this one 5 in parallel with 20, and then plus with 6 with 3 are in parallel. Oh, sorry, silap. Parallel. And then what should you do? You plus with 8. Yes, this one correct because you have inverse here, and this one also inverse and inverse. Okay, so this is the you understand my equation, right? Not equation, the calculation. If you do understand, then good. Then when you do the calculation using the calculator, then you use this part lah. Just make sure that you know what to do. So this is 5 inverse plus 20 inverse, and in bracket everything inverse. Okay, so please use your calculator. What do you get? I want to check your answer. Do you really know how to use calculator? Okay, cepat sebab kita dah habis masa. Okay, use your calculator. 5 and 20, what do you get? 200 by 25. Apa ni? 8. 24? Are you sure?
24.
24. Okay, nanti kita tengok. Do we have answer here? Oh, tak ada
Ada.
answer ke? Ada.
24.
24. Alhamdulillah. Okay, good. I think with that, I do understand you do understand my class. Okay. Okay. So, any question before we finish our class?
No, madam. No question. No question.
Okay. So with that, we finish our class, yeah? With tasbih kafara and surah al-as. Subhanakallahumma wa bihamdik asyhadu an la ilaha illa anta astaghfiruka wa atubu ilaik. Wal 'asr innal insana lafi